Hello students, in this video we'll take the next example of finding the resultant force when I know one force vector and I'm not knowing the other two force vectors. I'll show you the example wherein we have to find the the resultant acting along a particular line. In this example, again I'm having a concurrent force system, the point of concurrency being at this position, that is A. Now, I know the tension in AC is given to me as 20 kilonewtons. I have to find out the tension in AB and AD, that is along this string and this string, in such a way that the resultant of these three forces applied at point A is vertical. That means it has to act vertical along, the y axis, acting at point A. And I need to find the resultant as well, that is the magnitude of the resultant. So in this case, again, the first thing that we have to do is find out the coordinates. Now, origin will be 0, 0, 0. A. It is lying on the y-axis, so x and z coordinate will be 0. Y is given to me as 48. So 0, 48, 0. C is lying on the negative z-axis on the back side, so z coordinate will be negative 24. X coordinate will be 16, y coordinate will be 0 because C is lying in the xz plane. So 16, 0 minus 24. Then B, since again it is lying in the xz plane, y coordinate will be 0. So x is 16, 0 and z is positive 12. For D, it is lying again in the xz plane, so y will be 0 and x is on the negative side, so minus 14 comma 0, and since this point is lying on the x-axis, the z coordinate will be 0. Now I have got the coordinates. Now what I need to do is I need to find out the force vectors, that is TAC, TAB and TAD as in vector form. So first I'll find out for TAC as a vector. For that I should be knowing the magnitude and the unit vector along AC. Happens to be my force vector for AC. Similarly, I need to find out the force vector along AD. For that, I should be knowing the magnitude and the unit vector along AD. Since I don't know the magnitude along AD, I'll keep it as unknown AD, but I can find the unit vector, so that will be Similarly, I can find the force vector for AB. I don't know the magnitude in this case, so I'll just keep it as it is and I'll find the unit vector for AB. So that will be now what I have got over here is the force vectors for the three forces that I'm having, that is along AC, AD and AB. Now what I need to do is, I know that the resultant is going to act at A. The resultant is going to act at A and it is going to be vertical. That means it is going to be along the y-axis. So if I take the component of the resultant, so what is going to happen in that case is the component along x-axis will be 0, along z-axis it will be 0. I'll be having some magnitude along y-axis. So I won't say that ry is 0, but I can say that rx and rz will be 0. So similarly what I'll do is, I'll first take the summation of the x components of these three forces, then the y components and the z components, and then I can equate all these three components with rx, ry and rz. Now I know that my resultant will be nothing but and in this case my r is, I can simplify this r as rx, ry and rz, which is along I, y and I, j and k caps. So I can write the forces and the magnitudes as I, j and k. So for AC I'm having 5.71 minus 0.28 TAB plus zero point 0.3 TAB. This is along I. Similarly, I can write along J. You can see that I have just done the summation of I components 5.7, 0.28 TAD and zero point 0.3 TAB. Similarly, I'll be doing for J. So that will be minus 17.28 . Now, once I have got the components along I, J and K clubbed together, now I can say that Rx will be equal to this component, Ry will be equal to this component and Rz will be equal to this component. So Rx is now after equating this, I know that since since resultant is acting along y-axis, Rx equal to Rz equal to 0. So I can equate it as 0 in the above equations. If I do that, in this case, I can find the tension along AB. So my equation will become so I have got tension along AB as 37.56 kilonewtons. Now if I substitute this value of AB in the first equation for Rx, so I can get this value, I know this value, I can find the tension along AD, and Rx is 0 in that case. So therefore now I have got the tension along AD as well. Now what I need to do is, I know tension along AC, I have calculated along AD and AB as well. Now I know that since the resultant is acting along y-axis, I just need to find out the resultant magnitude. To find out the resultant magnitude along y, I can just substitute the values over here for AD and AB so that I can get RY component. So the component along y happens to be minus 110.04. That means the force is acting downwards from point A. So if I just show it over here, the resultant force will be acting at A downwards. So this is how we can say that I have got the resultant. I hope you have understood this example. Thank you.